In this video, we are going to be discussing the differences and similarities between radians and degrees and going over how to convert them between each other to find the degree measurement of radian angles and vice versa. To start off with, we need to discuss something we talked about in a previous video, and how that is how to compare the two units. So we know that there are 360 degrees in a circle. And we discussed before that we figured out that if you have a circle with any radius length, you would be able to lay about 6.28 of those radius lengths along the outside of the circle to find its circumference. That is where the formula of 2 pi r, or 2 pi times the radius, comes from, because 2 pi is equal to about 6.28. So we can say that 360 degrees and 2 pi radians, and the most common abbreviation for radians is RAD, they are going to be equal to each other. So we can use this to then kind of go a little further. If I divided both of these sides by 2, I would get that 180 degrees are going to be equal to pi radians. What that really means to us is that we have an angle of 180 degrees, then there would be about 3.14 radius lengths that would fit around that angle. 180 degrees is a semicircle or half a circle. It makes sense there would be half as many radians as well. So right there we have the basis of what we'll need to then convert them between each other. So if I wanted to kind of use this, one way I could write this is if I divided both sides by pi, I would get that 180 degrees over pi would be equal to 1 radian. It's not incredibly important, but we could put that into any calculator and figure out that 180 divided by pi is about 57.29 degrees, or 57.3 degrees. So we could write that over here, but it's not really going to be something you're going to need to know off the top of your head at all. Alternatively, we could then do the opposite. We could divide both sides by 180. So we would have the idea that 1 degree would be equal to pi over 180 radians. And just like before, we could put that into a calculator. We would get an answer of 0.17 or 0.02 radians would be only a 1 degree angle. And if you think about, if you're looking at a circle and you made a central angle in that circle and that angle was 1 degree, you would basically have an arc that would be almost zero in length. It'd be very, very small, only looking at 1/360th of that full circle in units. So right there, we have some things that are important. So this 180 over pi right here, if that for every 1 radian, we know that it's this many degrees, about 57.3 degrees. What that means for every 1 radian we go up, or we would have to multiply by 180 pi for each of those 1 radians. And then conversely, if we go up by 1 degree, we would have to go up by pi over 180 radians. So what that means is that if we were going to go from degrees to radians, I need to multiply that number of degrees by pi over 180 in or not in a calculator. And then the opposite, if I wanted to go from radians to degrees, I would just need to multiply by 180 over pi. And you could set that up as kind of a unit conversion like you might see in a chemistry class, or just do some simple multiplication with fractions like you would do in any other math class. Now let's put this into our notes. To convert radians to degrees, you are going to multiply by 180 over pi. And since this is a fraction, we want to put that in parentheses. Now, this is something where you can just put that right in your calculator. When we're going to degrees, we just want our degrees as a number, and that could have a decimal or it could not. And we're not really concerned with that as much in this scenario. But if we were to do the same thing for the opposite, go from degrees to radians, we need to multiply by pi over 180. And this is going to be important to keep as a fraction and not have any decimals. So you're going to want to use a calculator or your math skills to keep this 180 or pi over 180 as a fraction and simplify your answer once you multiplied your numerators and denominators together. In pre-calculus and other classes in the future, you will need to know these exact radian measurements in fraction form or as rational numbers, as that will apply to a lot of different trigonometry concepts later on. So it's very important to take note of that. So we want to write out a note right here that we want to keep as a rational number or a fraction. In addition, we also want to keep that pi involved, because the pi is really what is going to make it into something that's going to be related to radians. So I'm just going to write underneath here, keep pi. And it's just not going to matter as much for the one up the top, the 180 over pi. You can just take that parentheses and just multiply by whatever your radian amount was as a decimal or as a fraction, and just write down your answer. So that's going to be a little bit easier for that sort of problem. And we're going to look at some examples now to go along with those notes. So make sure to write down what you're multiplying by to go from radians to degrees, 180 over pi, and then write down in your notes degrees to radians, multiplying by this upside down version of that fraction as we try these examples. We will now go through 5 different examples of converting from a radian measurement, you see all these have pi involved with them, to degrees. And here we're going to just use our calculator and find our answers from that. And depending on who you are, you may use more or less of the calculator part. So look at the number 1. If we have 2 pi over 3, we are going to multiply that by using our notes. So we're going to multiply that by, since we're going 2 degrees, we're going to multiply by 180 over pi. So you'll see that just based on what I have right here, if you think about how fractions work, well, I could try to cancel out some things or divide out some things in the top and the bottom, since this is all multiplication. The first thing I would do to simplify this would just be cross out the 2 pi values, since it's on the top and the bottom. That should be a good hint that you are going to be going to degrees, or what to use to go to degrees, because we're trying to get rid of the pi value since degrees don't have pi involved. So if you have pi in the numerator, you want to multiply by something that has pi in the denominator, so those can get canceled out. So the 2 ways to simplify this fraction is that we can just multiply across the top and the bottom. We could also simplify more, like I could divide this 3 by 3 and divide the 180 by 3, and that would give me 60. So then all I have to do to get my answer is 2 times 60 in the top, and I would just have a 1 left over in the bottom, meaning that my answer is 120 degrees, is equal to 2 pi over 3. Moving to problem number 2, we have 5 pi over 4 that we can multiply by our tool from our notes of 180 over pi. So just to kind of demonstrate another way to do this, just for this version of it, is that you could just take a calculator and multiply 5 pi over 4 in parentheses by 180 over pi in parentheses. And the calculator gives me an answer of 225 degrees in this case. And we don't really have to do any other steps other than just putting all that right in our calculator for this particular one. So now moving on to example number 3, we have 3 pi over 2. And that is being multiplied by 180 over pi. So some things that will start being easier here is that we can cross out the pi's right away and divide this 2 by 2 and divide the 180 by 2 to get 90. And 90 times 3 is going to equal our answer of 270. So now with this sort of thing, you can kind of look for these shortcuts. The shortcuts that I'm referring to are kind of those whole radian angles that kind of match with degrees. So you can see how we know from before that pi and 180 degrees, well, that is going to be something that is going to be easy because pi is half of 2 pi. 2 pi is 360 degrees. So I don't even have to do this. I know that that is 180 degrees. So if that's the case, if I know I did pi over 2, half of pi is going to be the same as finding half of 180. So I know right away that that is going to be equal to 90 degrees. If pi is 180, pi over 2 has to be 90 degrees. And you can remember that pi being 180 is going to be an example that's going to be useful in a lot of problems, because if you think about something like pi over 2 is 90, pi over 3 would just be 180 divided by 3, which equals 60. You could do pi over something like 6. Pi, or 180 divided by 6 is going to be equal to 30. And those are some shortcuts by just thinking about 180 and pi being the same. Last problem, we have 7 pi over 6. It's a little bit harder to convert this one than some other ones, but it's not going to be too challenging overall. So we got 7 pi over 6. We are multiplying that by our 180 over pi conversion fraction. And if I know that, I can kind of do as before, cross off my pi value, and I can divide this by 6, make it a 1, and divide 180 by 6 and make it 30. And then all I have to do is 7 times that 30 and get an answer of 210 degrees. So that's just showing all the different kind of problems you could be asked to go from radians to degrees. And it is a very straightforward process following the step of just multiplying your radian measure by 180 over pi, and then either using some fraction simplifying steps or going right to your calculator to find your answers. We are now moving on to doing the opposite operation, where we are going from degrees to radians instead. So we're going to be multiplying instead with all of these problems. We're going to be multiplying by our conversion fraction, which is pi over 180 degrees. So we're going to be using that to multiply all of these. And the key thing to remember is that when we are multiplying all of these angle measures are all over 1. We want to make it into a rational number. It's easy to multiply by the fraction we just circled up at the top. So I'm going to multiply this by pi over 180. And we can kind of put these together into one fraction of 120 pi over 180. And then depending on who you are, you might kind of put this into and have your calculator help you find the fraction. Or if you know the 120 over 180, you can simplify that all the way to 2 pi over 3. Moving on to problem number 2, we have 300 we would write over 1, and then we would have it as being multiplied by pi over 180. So if we have that written out, well, we know that that's going to end up being 300 pi over 180. That part is straightforward. But the simplifying of that fraction is a little bit harder because we've got to try to find the biggest numbers that go into both. So one thing we could do to start off with is just cross off the zeros in the problem. So we can just have 30 over 18. Well, then I know that 6 is the biggest number that goes into 30 and 18. So I could kind of cross out the 18 and make that a 3, and cross off the 30 and make that a 5. So I know that my final answer for number 2 would then become 5 pi over 3. So that kind of summarizes that problem right there. Moving on to number 3, we have 210. So we have 210 is now being multiplied by our conversion fraction of pi over 180. And when we multiply that out, we have 210 times pi over 180. And we could even simplify without putting it all together first if you were so inclined. So I know that 30 goes into 210 and 180. So I could divide 210 by 30, and that is 7. And 180 divided by 30 is 6. So that means that 7 pi over 6 radians would be then equal to 210 degrees. So now we look at number 4, we see negative 150 degrees. So generally speaking, with these circles, you will find more about this in future topics. But if you are going counterclockwise on a circle, technically that is positive degrees. And if you go clockwise in a circle, that is negative degrees. So this negative 150 degrees would be the same thing as going clockwise 150 degrees if you were starting on the kind of the right-hand side of the circle. But for right now, we don't really need to worry about that part. We just need to convert negative 150 to radians. So making it over 1 first is step number 1. Multiply by pi over 180. And we then can just kind of look at our numbers. Well, I know 30 goes into 150 and 180. So I can just kind of cross them off. So that would become a negative 5 divided by 30. And this divided by 30 would be 6. So my final answer is negative 5 pi over 6 radians. And that brings us to our last problem of the video. We're converting 60 degrees. If you recall my tip from earlier, we know that pi is the same thing as 180 degrees. So if I divided both sides of that by 3, I would get that 60 degrees and pi over 3 would be the exact same thing. So that's an easy way to kind of come to the answer that 60 degrees is going to be equal to pi over 30, over 3, I mean, radians. And that you find that same answer by just multiplying 60 by pi over 180. And that covers the relationship between degrees and radians and how to convert backwards and forwards between these two units of measure for angles. Thank you for watching.